All right. So the survival package has changed a lot over the years. I divided into kind of four eras. Before the White Book, before there were formulas. Then the kind of 1.x and the S plus series. I actually talked about this at the second International S Conference in Toulouse. That's the last time I was in Toulouse. The sideline of that is that it's been 30 years and I still haven't finished my first package. So maybe you want to be more efficient than me. Then kind of 2, and now I just started 3.x. It's just got put on GitHub a few days ago, and hopefully there'll be a book in another year that will carry on with things, and it should get on Crayon in another month. Why should you care about this is the reason I don't change version numbers very often, so something must be going on. And there are, as a few days ago, 701 packages that depend on survival. So it might affect... There's 701 packages that depend on survival, so it might affect you whether you like it or not. The big change is multistate modeling. Why am I worried about multistate modeling? Is because I work in a medical center and these are the problems I see. In the upper left, you see what I was working on 20 years ago when I first started. Everything was just yes, no, alive, dead, recurrence, not recurrence. The upper right, you see things that I was beginning to see when I wrote my book in 2000, where you see multiples of events, multiple infections, multiple recurrences of MI, and you get the Anderson-Gill model that I talked about then. The lower left is what I see all the time now, is competing risks. This was an example that started me thinking about it. This is people who are waiting for a liver transplant, and you either get a liver transplant or you die on the list, or few people transfer to another center. I hate to say it, liver transplant is dominated by the fact that about 4 people get added to the list for every liver that becomes available. So that's the dominating thing there. But the right is what I'm seeing more and more now, more complicated models. And I'll use this as an example. This is a study in leukemia, where the idea is that people come in, they get an initial treatment. That initial treatment puts them into complete response. You let them recover from that initial treatment a little bit, and they do stem cells, hardcore treatment and stem cell transplant to consolidate the response, and hopefully they go into long-term remission then. Eventually, though, they will relapse. The data really looks like this. There are some people who go straight from initial treatment to relapse. They never got a complete response. They never got stem cell transplant. Some people get stem cell transplant without getting a CR. There's even a couple people who got CR after their stem cell transplant. You see a little arrow coming back. So you get arrows all over the place, and I've got to think about this data and how to deal with that data. And of course, there's always that box at the bottom in any study I work on. Okay. The answer is, if you can make your data set look like this, you can deal with that data. Here's the data set for that data. I've only got one covariate here. So I've got a subject ID. I've got a single covariate just to make it fit on my slide. There's only treatment. And then you've got time intervals for each person. And each interval has a finish. So person number 1, they got a CR on day 44, complete response. They relapsed on day 113. They died on day 235. So I've just got these intervals. The second person had a stem cell transplant on day 200, died on day 286, didn't have anything in between. This person got a complete response on day 38, and 1893, they still are in complete response, and they haven't transplanted them yet. Nothing bad has happened, so people are kind of all over. That's the data set, and I don't know what I did to make that happen. Okay, but it went away. So this is the key. Your data is... You've got an event is simply a multi-level class variable instead of being a 0-1. That's the key thing. The first level has to correspond to nothing happened at this time, but otherwise it can be anything you want. You can have any labels you like, any order you like, just as long as that first level is nothing happened here. You need an ID variable for multiple events per subject, and you'd like your data set to be consistent. What do I mean by consistent? If someone's at risk, they should be somewhere. Here's my data set for someone who's taking a vacation in France. They come into Paris. On day 50, they go to Toulouse. And from 90 to 210, it says there's an interval from 90 to 10 when they went to Marseille. Where were they from 50 to 90? That doesn't, I can't do multi-state modeling if you don't tell me where they were. Here's someone else who came to Toulouse on day 50. And then they got a second interval from 30 to 210 when they went back to Paris. But there are 2 copies of them at the same time in Toulouse. They could meet each other on the street. That isn't good. You only want 1 copy. So That's the basic rule of your data set. Make it look like real people. You can have multiple event variables. I'm actually going to use this as my event variable. So I made a second event variable for a interest, if I'm only interested in stem cell transplant and failure, where failure was the first of relapse or death. So here's a person, this is nothing happened here, they failed. Nothing happened here, they had a stem cell. Why do I say nothing happened here? They did not fail again. Okay, event variables are changes in state, not current state. And then here's someone stem cell, then they failed. Here's the CR person didn't do anything. And here's a case where I made the nothing happened here. I used minus as the label for it. I used to use blank for the nothing happened here case, but then it doesn't print very well. Okay, and here's how you fit this. This is, I just run surfit with that data set, ID variable, data equals my data, and this will give me an Allen-Johansson curve. So it looks just like the thing I used for Kaplan-Meier. Now I get Allen-Johansson curves, which are full multi-state curves. The dimension of the final thing is 2 by 3. It says there are 2 strata, there are 2 treatment groups, and there are 3 outcomes. So it looks like a 2 by 3 object. You can subscript it, you can print it. If you print it, you print one line for each, and it does the usual SR thing. You know, I've got a 2 by 3 matrix that goes this way, first column, second column, third column. I can plot it, and if I plot, I can actually say I only want to plot the probability of being in the second 2 states. I don't care about being probability, and this is what the plot looks like. That's actually the plot command that I actually used. Has got more stuff like line type, color, labels, all the decoration, but this is what you get. This particular case, this is a real study, by the way. You can see that treatment B is doing better than treatment A in terms of total number of patients who have failed. You can see that in terms of stem cell transplant, this is the probability of currently being in that state. That's what it's about, currently state. And there's nobody kind of in the stem cell transplant for the first 90 days, because it's by protocol. They didn't want to do it until you have a chance to get a CR and recover. And then if you look really close, the black line is a little bit ahead, that those who were on treatment A got transplanted just a little earlier than those on treatment B. But their transplants didn't hold as long. The treatment B people stay in that transplant state for longer before they convert to the failure state. If I were to draw all 3 curves here, which is entry, failure, not, they would add to 1, because everyone's got to be somewhere. Kind of a basic rule. And if you want to fit a multi-state Cox model, oh, okay. I'm sorry. I thought she was trying to get me so she could see the screen. If you want to fit a multi-state Cox model, it's the same thing. Cox model, you just use this special status variable. And presto, you get a fit. Now this is interesting. There's 3 transitions in that picture. So from 1 to 2, and you'll see down here at the bottom, there's a little legend that says what the states are. From 1 to 2, the people on treatment arm B had a little less fast going from entry to stem cell transplant. I noticed that before, that the red curve was a little later to get a stem cell transplant. They were also much later, by a bit more, at getting failure. And if they did get a transplant, they were slower to leave the transplant state and go to failure state. So all 3 of those things, treatment B was the better treatment in all 3 transitions. So it prints that for you. Okay? Okay. There we go. And you can get curves post-Cox. You fit a Cox model, you can get curves. And it's always for a Cox model, you get curves for somebody. You have to tell them what covariates you want. So you create a dummy data set. In this case, I've only got 1 covariate. So I'm going to say I want a curve for somebody on treatment arm A and a curve for someone on treatment arm B. You get the curve by asking it for surfit from a Cox model, and it will give you a set of curves, 1 for each of the data things you did. There's only 1 strata here because there's no strata on the Cox model, and 3 states, and I can plot those curves. So you get the Allen-Johansson curves post-Cox model, which are the right curves to get worse things. Okay, so what were the whole goals of this transformation that I did? I wanted to make getting multi-state survival curves Allen-Johansson's as easy as doing surfit. I think I did. I want to make multi-state fits as easy as doing Cox-PH, so I don't have to do anything special. Secondary summaries, they come out pretty easily. I don't show them. Expected time in state, number of visits to state, they're there. The real key was to have standardized data, that if you make the data be standardized, that it looks like real data, that means you can have better data tools. You know, you have to have the rules. People can't be in two places at once. They should be somewhere. Gaps and teleports are viewed as suspicion. What I mean by teleports in my Marseille? Somebody came to Toulouse on day 50, and the next interval starts at day 50.1, and they're in Arlane. How'd they get there? you have to be in the, you can't just jump states from place to place. But basically, try to make the data set look real so people don't have to break the rules. You can fit multi-state things with Cox models, with ordinary Cox models, by making special data sets that have people in them multiple times. That's possible to do. But as soon as you do that, people make mistakes, and immortal time bias is probably the biggest deal in survival now in terms of bad things in journals. So that's, I would try to avoid that. It's getting the robust variance bill for everything, so I can get correct variance with IP weights. If you're doing inverse probabilities, you get variance of derived quantities. You notice I had a variance of the mean response time. These are the tools that I use. This is why I'm doing it. This is what I do every day. I'm a biostatistician. I don't have students. I don't teach classes. I do data. A subset argument is I'd like to sunset the fine. I don't like the fine gray model, but no one's going to stop using it unless I give them better tools. And of course, the main thing, a lot of people use this, don't mess it up. If I make the survival package break for all your prior analyses, I'll have people at my door with torches and pitchforks doing that. Okay, here's last pieces. You can check your data. There's a check function, serve check, and you call it, and it will tell you for your data set, what are all the transitions? So here I can see 43 people went straight from entry to CR. Somebody went from this many went from CR to SCT. The most important line here is this one that verifies that I didn't have anybody go from death to some other state. That usually means there's a data error. Even Mayo's not that good in terms of coins. And there's a flag that tells me, are there any of these things I really don't like? Overlap, that's when someone's in two places at once. A gap, that's when someone has a hole in their follow-up. A jump, that's when someone has a hole in their follow-up, and when they came back, they were in a different state. Well, how'd they get there? And teleport is when they don't have a hole, and they still manage to get in a different state in 0 time. So, now this. You can do more complex Cox models if you want. This is because someone's going to ask this question. You can create a list that has a common formula for all the states, and then you can say, oh, for the transition from SCT to failure, I want one more variable in that formula. So hemoglobin is in the formula for those transitions, but not the others. And I can even have from, okay, I see that, from beginning state to SCT or failure, I want sex to be in that formula, but those two transitions should have common coefficient for sex. So you can do complicated things with your formulas if you want, and then you just fit it. So there we go. What are things yet to do? Naglevel, we're still debating that. I don't like software that complains at me all the time, but when there's something that's suspicious, if there's a gap, should the routine just go on its way and do it? And say they ran the check routine, trust, and they looked, they tested their data. Should it complain, put a warning message out all the time that says, I don't know if this is good? Or should it give an error message, say, no, I don't like this. I don't like the third, because as soon as I do that, somebody comes up with a use case where it actually is okay. So I got to decide how much thing. You notice this unnamed state that I had. Sometimes when people, if you don't tell them what starting state, it assumes everybody starts in the same state. And we've had various ideas for what we called it. We kind of settled on this, but I think it's okay that there's this state 0, unnamed state 0, where we put in parentheses, like the S puts intercept in parentheses. So say that this is the one I made up. Methods, I'm not all the way through this list. So there's square bracket, coef, plot, print, and VCOV work for multi-state models. Quantile, ANOVA, extract AIC, a bunch of others are not there yet. I haven't filled in all the pieces. I got a lot of work to do. I need to do more tests. I don't trust any software till I test it, and so I'm putting tests in piece by piece for the multi-state models. And then, of course, I get to check 500 other packages. I do that with the survival package. I actually run all the tests for all the packages that depend on survival. Or most of them. I don't run the ones that, there's a bunch of them that want me to have a GPU on my machine or GIS information, so I don't know those. You learn a lot from that. but I need to make those pass and then eventually put it on CRAN. That's where I'm tending to go. And I'm going to skip this. This is more argument about, I'll just say this. It's an argument that it really is important to do the curves, probability and state curves after a Cox model, because the hazards are not enough. You need probability and state to start doing causal inference. So those are really important. And I have made some progress. I finally have a sticker. And unfortunately, we printed a bunch, but then my colleagues took them all to the RStudio conference in Florida, and I only have about 7 left. So I brought them, and I'll just leave them there. Someone can have them. I should have a stack. And that's all. Thank you.
Excellent. So for the people that have nice questions, could they compete for a sticker? So who wants to compete for the sticker? Questions?
No questions? It's all perfectly clear, or it's all perfectly mud.
Okay, so we have one question.
Hi. Well, first of all, thanks for the survival package. It's awesome. Will there be support for multi-state models also for parametric models, or just for the Cox?
Will I do multi-state parametric?
Yes.
Not on my list.
Okay.
I'm driven by the data sets in front of me, and I need this. I don't need it parametric right now. So
Okay.
I don't have any users at my doorstep saying, where is my solution?
So he doesn't qualify for a sticker?
He qualifies. It's a good question.
We will see. There was a question up front there also.
So you mentioned immortal time bias being something that you have to worry about later, or that you've considered. How exactly are you considering in the multi-state model?
I'm saying that if I make it easy for people to make the data set, okay, immortal time bias comes most often when you goof up the data set. You make a covariate that depends on the future show up too early, things like that. So if I make it really easy for people to make the data set, that the data set is absolutely clear, this is people walking through time, that if they obey the rules, they're less likely to have immortal time bias because I've made it easy for the data. Okay, that doesn't stop people who do it on purpose. Okay.
Okay, I think we don't have time for any more questions, but you will probably be around afterwards.
I will be.
Thank you.